Okay, today we're going to make a foldable on mass movement. And so we're going to go ahead. If you look, this is basically your foldable right here. And this is the staple up at the top, and you've got your little flaps. So we're going to go ahead and label our flaps and label a title. So this is 5.2. And the title is Mass Movement. Oh, I'm sorry. The title is Water Erosion. Kind of regressing back to the last section. Okay, so we're going to label our flaps. So the first one is runoff. And our next flap is the amount of runoff. And then we have river system. And river erosion. River deposition. Groundwater erosion. And groundwater deposition. Okay, so now we're going to start with the very first flap, which is runoff. So we're going to actually lift up this top page and we're going to look up the runoff section. So runoff is actually just the movement of water as it runs over Earth's surface. So as water runs off of mountains, as it runs off of parking lots, as it runs down roads, that's considered to be runoff. So what I've drawn here is basically, this is on the back side of this is where it says 5.2 mass movement. So this is where we've opened up the flap, and this is like the little crease where the staple is holding the papers together. So in the top part of this foldable, we're going to write the definition of runoff, and then we're going to draw the picture that's going to represent the parts of a river and where runoff starts and where it ends up. So the first thing we're going to do is put our definition up here. This is the movement of water over Earth's surface. Okay, so there's our definition. And then what happens? So the water actually starts in little tiny grooves. These little tiny grooves are called rills. And then these little tiny grooves combine together to make bigger grooves called gullies. And then the gullies come together to form streams. And then the streams come together and make rivers. So let's label our parts. So we started off with rills right there. And then those rills came together to make gullies. And then the gullies came together to make streams. And then the streams came together to make rivers. Okay? And it always starts with the highest part, which would be the rill, and those would come together. It doesn't start rivers and then the streams to gullies to rills. It always goes smallest to largest. So rills to gullies to streams to rivers. And that's runoff. So then we're going to open up the next flap, which is on use of the land and the amount, which is going to be on the amount of runoff. So open up your next flap. Okay, so when we talk about the amount of runoff, this is the top what we just folded up. This is the midline where the staple is. So we just folded this piece up. So we have, when we talk about amount of runoff, it's going to require 5 main factors that affect how much water runs off the land. So we're going to write that up here. Okay, so there are 5 main factors that affect the amount of runoff. So the bottom part, we're going to actually divide into 5 different squares. Okay, the first main factor is the amount of rain. Alright, so what that means is I could have a very little rain, which is going to have very little runoff, versus a whole lot of rain, which is going to have more runoff. Another thing that can affect how well the water runs across the land is the vegetation. That's grasses and shrubs and trees and plants. This is an E. Okay, so if you've got a lot of vegetation, then you're going to have less runoff because the plants are going to soak up some of the water and the roots are going to hold the plants in place. So vegetation can determine how well the water runs across the land. So then we can also have the type of soil, because not all soil allows runoff. Some soil just soaks up the water like sand. So I'm going to type this because my writing is hard to read. So if I have sand, then the water is not going to run off really well. The water is just going to permeate through the soil. It's just going to go down into the soil. But if I have clay, the water is really easily going to run off the soil. So the type of soil makes a difference about how well water runs off the land. Also, you have the shape of the land. Okay. So if I have really steep land, then more water is going to run off than if I have land that's pretty flat. The water's just going to pool. It's going to sit there. So the shape of the land also affects the amount of runoff. And the last thing in this last box we have the use of the land. How do people use the land? How do animals use land? Because that can affect the amount of runoff. So if we make parking lots, then we're going to have a lot more runoff than if we have grass, because the grass is going to help soak up. So let's see if I can make a parking lot here. Okay, so as you can see, I kind of cheated there. I used my emoticon keyboard to make some little cars and park them in my parking lot. So what's going to happen is when it rains, the water is just really easily going to run off of the parking lot. It's not going to get soaked into the pavement. And that's all we have for amount of runoff. So now we're going to open up the next flap, and we're going to do a river system. So if this is your page, with the fold right about here, and you already had river system written down at the bottom, we're going to talk about the parts of a river system. So we're going to start at the top of the page on that part you just folded up. We're going to draw a mountain. Now, what happens is when it rains, this mountain, we're going to give it a title. It's called a divide. Okay, it's the Great Divide. Okay, it divides the two halves of the land, this side from this side. It's right in the middle. It divides it. So when this snow that's on the top of my mountain melts, and when it rains, the water will go down both sides. And on the bottom of the mountain, the water will collect. And sometimes it collects on the surface, and sometimes it collects underground. And that is called a drainage basin. So on both sides of my mountain, a drainage basin on one side, drainage basin on the other. Okay? Now, eventually, the water is going to get so full that it's going to spill out. Oops, I didn't realize that I just changed that to blue. Okay. So the water is going to get so full that eventually it's going to spill out. Okay, and these little streams, it comes out of the drainage basins. It eventually comes together to make a river. Now the streams that pour into a river, or smaller rivers that pour into larger river, are called tributaries. So these are called tributaries. And that's the parts of a river system. So now we're going to turn the flap, and we're going to move on to how rivers erode the land. Okay, so there are five major landforms caused by river erosion. So we're going to take the top of the page, divide that one in half. Okay. First type of landform that you might find is a valley that's got a little river running through it. Okay. And this valley is called a V-shaped valley. Okay. Something else you might find is a waterfall. Okay. The bottom half of that flap we'll go ahead and divide into 3 parts. And landform that you're going to find with water, it might be a floodplain. And you actually in West Point live in a floodplain, where most of West Point is land, but it's lowland, and the rivers can flood at any moment. And where the river can flood is considered to be the floodplain. Now, usually on each side of the river, you're going to have a riverbank. It's kind of a natural levee. It's kind of like a high area. I actually would like to draw it better like this. Okay, so it's like a high hill on each side. And the river is just going to flow right through. Now, on occasion, if the river has too much volume of water, then the river will overflow its channels and into this floodplain, into this green grassy area on both sides. Just like on occasion, when West Point or our area has too much water, it's going to flood into our town. So this is called floodplain. Another thing that might happen is that a river is going to take the path of least resistance. So if there's rocks, really thick soil that the water just can't push through, the river is just going to kind of curve and follow the easiest path that it can do. Now this is a meander. The river meanders. And you can use the term meander like a student might ask to go to the bathroom, and he may meander trying to get there. He may stop off at the math class and then stop at the water fountain and then go stop at the social studies class and stop at the office and finally get to the bathroom. That student has meandered. So when a river meanders, it takes loop-like bends because it took the path of least resistance. And the last formation you might see is sometimes a river meanders. Now don't draw this yet because I'm going to make a change in just a second. And sometimes the river changes, and it was flowing this course, but something got in the way, and now it flows this course. And this piece has been cut off from the rest of the river. This loop that got cut off right here, this loop that got cut off is called an oxbow lake. So sometimes that formation might occur during river erosion. Right there. Okay. So open the next flap to river deposition. Now, when a river flows, it picks up sediment. And when it slows down, it drops the sediment. So we're going to talk about where rivers flow fast and where they slow down. And where they slow down, they drop sediment. And those sediment has a term. So we're going to draw, the first one's going to be alluvial fan. So we're going to draw a mountain range. And we'll put some snow on top of the mountain. Now, the water coming down out of the mountain is going to flow really fast. Okay? Well, when it hits the bottom of the mountain, it's flowing really fast down the mountain, but when it hits the bottom, just like when you sleigh ride down a mountain, you're going really fast, but when you hit the bottom, you slow down and then you stop. Well, the same thing happens to the sediment in the water. It slides down the mountain, but it slows down and stops at the bottom. And so you will see sediment that is collected at the bases of mountain because it was riding the river down and then it slowed down. And these sediments are called, or these depositions right here and right here are called alluvial fans. Okay, so that's an alluvial fan. It's when sediment is deposited at the base of mountain ranges. Now, if you look at the Mississippi River, we know that that carries a large abundance of sediment. And it's flowing down from north to south, down the United States. But when it hits the Gulf of Mexico, it slows down. Okay, it's going really fast, freely, and then all of a sudden it hits a big body of water. And right here it slows down. Well, it was carrying all this sediment with it. Okay, but when it got to the Gulf of Mexico, it lost its strength, lost its power, and it dropped the sediment. Well, where a river drops sediment at the mouth of a large body of water, we call that a delta. So this is called a delta. When it comes out of mountain ranges, it's called alluvial fan. When it comes out of a river meeting a larger body of water, it's called a delta. Okay, we're going to turn the next flap and we're going to talk about erosion. In particular, groundwater erosion. And we're just going to write a couple of things in this flap. So groundwater, so even the water underground causes erosion. Through chemical weathering. What it does is it dissolves the rock, creates something new. And what you're going to see is that water and carbon dioxide will come together and form carbonic acid And this usually happens to limestone underground. And when the carbonic acid will chemically change the limestone. Whoops. So that carbonic acid is going to chemically change the limestone. And so groundwater is actually eroding the land where you can't even see it. And so if you go to a cavern, you'll be able to see how the groundwater is still shaping the ground underneath. So we'll move to the next and last flap. So you will see that the water will drip from the ceiling of a cavern, and that'll create a stalactite, and then it'll drip deposits down to the floor, and that'll create a stalagmite. Now, how do you know the difference? Okay, so I've magically made these words and arrows appear. And so a good way to remember that a stalactite is one that's coming from the ceiling is the C can stand or remind you of ceiling, and the stalactite is holding on tight to the ceiling in hopes that it won't fall. And then we have stalagmite. The G is for ground, and we hope that the stalagmite might reach the ceiling someday. And when the two come together, which you will see happen sometimes, you will get what's called a cave column. Okay? And so those are some depositions that you might find underground based on groundwater erosion.